In this topic, we introduce first of all solar energy, its important application and some equipments. Introduction of solar energy. Sun is the largest member of solar system with other members revolving around it. It is sphere of intensely hot gaseous matter with a diameter of 1.39 into 10 raised to 9 meters and average distance 1.5 into 10 raised to 11 meters from Earth's surface. Sun is an effectively a black body temperature of 5777 Kelvin. We also known as it is the surface temperature of Sun. It is effectively a continuous fusion reaction. There is a fusion reaction takes place in sun. Reaction taking place in the sun is the conversion of hydrogen to form helium. According to Einstein's equation, E is equal to delta mc square, and this equation shows that hydrogen H2 plus H2 converted into helium and it exhibit 25 MeV, 25 mega electron volt. So this energy is produced at the interior of solar sphere at temperature of any millions of degrees. Now you all are see the structure of sun or layers of sun. In the center part, reddish color is known as core part, and after that radiative zone, and then convective zone, and then photosphere, and then chromosphere, and then corona. This is the sixth part or layer of sun. We also study two other matters. One is sunspot and one is sun flare. So, first of all, we start from the center of sun, that is core. The core is the center of the sun, the same name for the center of an apple. This is where all the sun's energy comes from. We see above reaction from hydrogen to helium. It is takes place in this core part. Second is radiative zone. The radiative zone is the zone around the core and it produces gamma rays and X rays that move core's heat energy towards the surface. After this, it is known as convective zone. Convection is when heat rises and colder gas, liquid or plasma sinks. The convective zone is made entirely of boiling plasma, ending heat up the sun's surface. According to some theories, there is a temperature of core part is 1.5 crore Kelvin. So at this temperature, most of matter is in core part as a plasma. After convective zone, next layer is known as photosphere. Photo means light. The photosphere is like a surface of light that covers the sun. The remember this, I think of photos on a sphere. After this, it is known as chromosphere, a layer of Sun's outer atmosphere. The chromosphere is reddish glow. Chromo means color and sphere means ball. So it's a ball of color around the surface that can be seen during an eclipse. I like to remember this word by the first sound crow, thinking of how they can fly around above the surface. After chromosphere, it is known as corona. This is not COVID 19, it is Sun's layer corona. Corona means crown in Latin. This outermost layer of the Sun's atmosphere can also be seen during the eclipse, like a crown surrounding the Sun. In full Sun eclipse, we show this corona at very good structure. We studying here six all parts of sun. Next, sunspots. The sun same times got spots on this surface that are darker and cooler. And last one is solar flare. The sun is so active that sometimes the energy bursts out with the flare. We also known as sun is a hot gaseous sphere. So we show solar flare at surface of the sun. Now it is all parts, all eight are described here together. This figure shows the some sun structure and radius of different types of layers. It is estimated that 90% of sun's energy is generated in the region of 0.25 r, that is the radius of sun. It is shown in figure here, radius of sun, where in its average temperature is not described in this figure but it is shown in next, but we study here its average temperature and density are 40 into 10 raised to 6 Kelvin and 10 raised to 5 kilogram per meter cube respectively at a distance of 0.75 r, that is the here 0.75 r. From center, the temperature dropped to about 1.3 into 10 raised to 5 Kelvin and density 70 kilogram per meter cube. Outer most layer of this zone is called photosphere. We show it above. Above photosphere is layer of color gases or several thousand kilometers deep called reversing layer. Outer layer is chromosphere. Energy in the form of photochemical waves. The amount of energy intercepted by Earth is about 17 into 10 raised to 18 kilowatt, which is only a tiny duration of total energy release by conversion of 4 million tons of hydrogen per second to helium in the sun. Please note this is the main point. In fusion reaction, 4 million tons of hydrogen per second to helium. So we have much more energy from the sun. This figure shows the different distance, layers distance from each other. This figure also shows some temperature, density and distance of each other layers. This figure shows different layers temperature. And this figure shows different layers and their particular matter. The total gradient flux of the sun is about 17 into 10 raised to 18 kilowatt, and the energy is stored on a earth surface of each year by radiation of hot solar rays and the rate of 1.35 kilowatt per meter square, which may be about 55,000 times more than the world's energy requirement during the next century and 50,000 times more than the present days energy available from all sources. Thus, in principle, solar energy can supply all the present and future energy needs of the world on continuous basis. This make it one of the most promising unconventional energy sources. So we studying the solar energy as non-conventional source. Now, the advantages of solar energy. It is a clean fuel and freely available in almost all parts in the world, unlike fossil fuel and nuclear fuel. At present day, we we have only two these sources for our energy. One is fossil fuel, that is petroleum, coal and natural gas, and second is nuclear fuel. And all these sources are limited and their stock is also limited and formation of its are very long time. So we have changed our scenario to non-conventional energy sources. Problems of solar energy. It is dilute source of energy. Hence, large collecting areas are required. Many applications and results in higher cost. And number two, variation and availability occurs daily because of night cycle and also seasonally because of Earth's orbit around the sun. Now, solar energy utilization. We have two methods. One is direct method and second is indirect method. In direct method, we have thermal application and photovoltaic application. And in indirect methods, formation of water power, wind energy, biomass, wave energy, and ocean temperature difference. So, in this unit, we studied detail about these direct and indirect methods. In this lecture, we studying detail about sun and temperature, distance, density, etc. parameters of different layers. I have one videos, so I attach it. You all are see. In this video, we see about the sun's layer. 6 layers of sun: core, radiative zone, convective zone, photosphere, chromosphere, and corona. 3 are internal layer and other 3 are outer layer. Center part of the sun is known as core. Its distance and temperature 1.5 crore Kelvin, and there is a fusion reaction, and all matters are in core is in plasma state. Second is radiative zone. Its distance, temperature, next layer is convective zone. Its distance, temperature, next one is photosphere. Its distance, temperature, photosphere is like this. And chromosphere. At a full sun eclipse, we show this structure. And last one is corona. And this is distance, temperature. We study two other parts of that is the corona. First of all, we see solar radiation on Earth's surface. Solar radiation is received at the Earth's surface is subjected to mechanism of absorption and scattering. We studied unit process absorption. Scattering is not studied. As it passes through Earth's atmosphere. Absorption occurs primarily because of presence of ozone and water vapor in the atmosphere, and lesser extent due to presence of gases like carbon dioxide, carbon monoxide, nitrogen dioxide, oxygen, methane, and particulate water. On the other hand, scattering occurs due to all gaseous molecules as well as particulate matter in the environment. The scatter radiation is redistributed in all directions, same going back to the space. The atmosphere at any location on the Earth's surface is classified into two groups. Number one is atmosphere with clouds, and number two is atmosphere without clouds. This is the structure of atmosphere. We show here in figure sun is radiate the its radiation. It is passed through the our atmosphere. In atmosphere is porous medium, and some gases we say above oxygen, carbon dioxide, ozone, water, carbon monoxide, dust, etc. are present in this atmosphere. Now, the types of radiation. In this topic, we are studying three types of radiation. Number one is beam or direct radiation. Number two is diffuse radiation. And number three is total or global radiation. We see one by one. Beam or direct radiation. Solar radiation received at the Earth's surface without any change in direction is called beam or direct radiation. This is not that the change of direction is not permissible. In this radiation, the change in direction is not permitted. Number two is diffuse radiation. Radiation received at the Earth's surface from all parts of the sky hemisphere after being subjected scattering in the atmosphere is called diffuse radiation. And number three is total or global radiation. The sum of beam radiation and diffuse radiation is called total radiation. So, number 1 and 2, sum of number 1 and 2 is known as total radiation. Now, we see the figure for structure of air mass. So, what is the air mass? Measure of the distance traveled by beam radiation through atmosphere before it reaches a location on Earth's surface is called air mass. Here is the structure of air mass. In figure we shows sun emits the radiation and it passes through our Earth's atmosphere and goes to Earth's surface. All types of radiation which are directly absorbed. We see here in figure this radiation is directly on Earth's surface, not change in direction. So it is direct radiation or beam radiation. But here shows some arrows are irregular, so it is known as diffuse radiation and its direction is changed by scattering process, atmosphere, some gases, water molecules, etc. This is also the figure for the total radiation, diffuse radiation, and beam radiation. This figure also shows the types of solar radiation. In this figure, we describe different colors for the types of solar radiation. Next topic is for solar radiation is instrument used for measuring radiation. According to our syllabus, we are studying three instruments for the measuring of solar radiation. Number one is sunshine recorder. Number two, pyranometer. And number three, pyrheliometer. So, first of all, we start with sunshine recorder. See the figure of sunshine recorder. We see the parts of sunshine recorder. First part is we show as spherical lens, which is reflect the sun rays. Next one is paper strip, which is indicate the sun rays. This one is support for paper strip, and last one is supporting base. Now we see the construction of sunshine recorder. The sun rays are focused by a glass sphere to a point on a card held in a groove in a spherical bowl. Here is the spherical bowl where card is mounted. Mounted concentrically with the sphere. Whenever there is a bright sunshine, the image from is so intense through the burn a spot on the card throughout the day as sun is moving around the earth or sun is moves across the sky. The image moves along with strip, thus a burnt trace whose length is proportional to duration of sunshine is obtained on the strip. This is the actual photo of sunshine recorder. In photo we show clearly there is a card or a spherical lens. This is the glass sphere which reflect the sun's rays, and here we show in below there is a vertical bowl, a paper card is mounted which indicate the solar radiation. This is the card which is used in the sunshine recorder. I have a video for this instrument, so at last I attach it with here. Next is pyranometer. We see above there are three types of radiation. Number one is beam or direct radiation, diffuse radiation, and number three is total or global radiation. Here is the pyranometer for measuring global radiation. First of all, we see the different parts of pyranometer. We see first part is glass dome. Here is two concentric glass are in dome type. This is the black body and it detects the sun radiation whole day. Next is sun shield which is supporting the instrument. Next is connector which record the sun radiation, and this connector is connecting with the other electric instrument. Now the housing and one is bubble level. Bubble level indicates the leveling level. Here next part is fixed foot, which is in fixed position, and last one is adjustable feet, which adjust up and down, and it is level of bubble level at a center in use of this adjustable feet. So this is the pyranometer for the measuring of global radiation. It is an instrument. It measures either global radiation over a hemispherical field of view. It consists of a black surface which gets the heated when exposed to solar radiation. Its temperature rises to the extent such that rate of heat gained by solar radiation is equal to rate of heat loss by conduction and radiation. The hot junction of thermopile. It is the hot junction of thermopile. Hot junction of thermopile are connected to black surface while cold junction are in plus where no radiation are coming. As a result, EMF electromotive force of is generated which is in the range of 0 to 10 millivolt, which can be read, record and integrated over a period of time and is a measure global radiation. So this is the pyranometer. Now actual photo of pyranometer is shows here. These are also the pyranometer and it is joined in field. For diffuse radiation measuring, we have this type of pyranometer. Two concentric hemisphere 30 mm and 50 mm diameter made up of optical glass having excellent transmission characteristic are used to protect circular disc to 25 mm diameter in any season. It can be also used to measure diffuse radiation. This can be done by measuring it at the center of the semicircular shading ring. The shading ring is fixed in such a manner that its plane is parallel to plan of path of sun's daily movement across the sky and it shapes the thermopile element and two glass domes at all times of direct radiation received from the sky. So this is the pyranometer for measuring diffuse radiation. This is the sunshine recorder. We see the strip or paper card in vertical bound. Whole day the glass domes are reflect the sun radiation and burnt out a card. We show here burnt out. sunshine recorder. This is the second video of sunshine recorder. Card paper on which burnt out process show we show the radiation gain. We show the bright radiation on card paper. Take care of you and your family. Thank you.